My name is Basitilios and I'm going to talk about question number 9. And the question number 9 says that the acceleration of a particle as it moves along a straight line is given by a is equal to 2t minus 1 meter per second square, where t is in seconds. If s is equal to 1 meter and v is equal to 2 meter per second when t is equal to 0. Determine the particle's velocity and position when t is equal to 6 seconds. Also determine the total distance the particle travels during this time period. So in this question we are given with the equation of acceleration as a function of t, and it also has given that the displacement is 1 meter and velocity is 2 meter per second when t is equal to 0. So we are given with these two values, which shows that the particle doesn't start from rest. It already had covered some distance, as well it has some velocity when t is equal to 0. So we are here to find three things. So one is the particle's velocity and its position when t is equal to 6 seconds. So we have to see that when t is equal to 6, what is particle's velocity at that time and the position as well. And the third thing we have to find is the total distance the particle travels during this time period, which is from 0 to 6 seconds. So let's start a solution. That's how we start our solution. So first we write out our points which are already given in the question. So we are given with the acceleration equation and then the displacement and velocity when t is equal to 0, and there are three things we have to find: displacement, velocity when t is equal to 6, and the total distance traveled between 0 and 6 seconds. So as the equation of acceleration is given, we can use integration to find v and s, because acceleration is already given as a function of t. So as acceleration is rate of change of velocity, so we can write a is equal to dv over dt, and then we can take dt on the other side with a and becomes dv is equal to a dt, and then we can use integration. We can put a limit t over here because acceleration is in form of as a function of t, and over here we put the upper limit to v because this is in form of v, and the lower limit here we have to be careful because as it is in form of t and t starts from 0. So you can see t starts from 0, so that's why we put the lower limit over here 0, but over here it's 2 because at rest v was 2 meter per second, so we have to put over here 2. So in some questions it's given like it starts from rest or it's is equal to 0, so we assume the lower limit is 0, but over here it's is equal to 2. So we use the integration method, and over here is equal to minus 2. We take the minus 2 on the other side and we get this equation in form of v, which is v is equal to t square minus t plus 2. Now we have to find the equation for displacement. Displacement is, for that we use this equation, which is velocity is the rate of change of displacement. So v is equal to ds over dt. So we take dt on the other side and we use the same method as we used above for acceleration and velocity. So same relation between velocity and displacement over here. So over here we put s as a upper limit and t over here. So instead of v it's s over here. So same procedure, just the symbols are changing. But in the lower limit we put 1 over here because s was 1 when it was t was is equal to 0. So we use the same method and same approach as the previous integration method. So it is really important to follow the steps, and then we do the integration. We get -1 over here, we take it to the other side, and we get the equation of displacement in form of t cube over 3 minus t square over 2 plus 2t plus 1. So we have the equation of displacement and velocity, and we have to find when t is equal to 6. So we have these two equations in form of t. So we replace t with 6. So we get the displacement 67 when we put the values in place of t. This is the particle's position when t is equal to 6 seconds. And same approach for v, we put the 6 in place of t, and we get 32 meter per second, which is the particle's velocity when t is equal to 6 seconds. And now the final thing towards the total distance traveled, which is between 0 to 6, and we subtract 67 minus 1, which is 66 total distance the particle travels during this time period. So in distance, it's like we have to keep in mind that it says that during this time period, which means from 0 to 6. So in displacement, you can see it says 67. 67 means that it also adds the 1. Like 1 meter over here was already covered. And then it further travels from the initial point, and at 6 seconds it's at 67 meter. But when we're specifically talking about the time period between 0 and 6 seconds, we have to keep in mind that we have to subtract any distance traveled by that particle before that time, which was 1 meter, because at 6 seconds it shows the total displacement from its original position. So that's why we have to subtract that 1 from here, and we get the total distance of particles has traveled during this time period. So this was the solution of this question. Thank you.